Today's session will focus on showing an understanding of the methods of file organization and how to select an appropriate method of file organization and perhaps file access for a given problem. We're also going to be looking at what the different methods of file access are and show a deeper understanding of hashing algorithms that are used to access data within files. Now, computers are used to access vast amounts of data and to present it as useful information all the time. Now, just like everyone else, you perhaps have used the internet to find some data which is stored in a file in a useful form. Now, files can store data about movies, products, airline tickets, hotel bookings, you name it. And we will need to search these files to retrieve information quickly. And data of all different types is stored as records in these files. So connecting to what we were learning about previously, those user-defined data types are used to create a model or a representation of the real world. And it's not just enough for us to store data in a file, but we also need to query it to find it and at speed so we can do something about it. So the focus of this particular lesson is to look at how we can access that data, those user-defined types, using different methods of file access and organization. Now, before we begin, let's pause and do a prior knowledge check. Think about what is meant by file organization. What do we mean by the term file organization? What is the difference between serial and sequential? Do you know what these words actually mean? What is meant by direct or random access? Now, you might have come across these terms at IGCSE or previously as you must have been trolling the internet. Do you actually know what they mean? So pause the video, just have a bit of think about this. Okay, so hopefully you know what these terms actually mean, or perhaps you've looked them up. Either way, you should have found out that file organization is the way that records of data are physically stored in a file, and that includes their structure and the order of the records, so how they're stored. Okay, so we're just organizing the records and we're storing them in a particular file. Whereas when you talk about file access, that's the method we use to physically find a record in a file, okay? Pretty important key terms, these two. Now, what about serial and sequential? Serial is basically a method of organization in which records of data are physically stored in a file, one after another. So it's time-based, it's time-stamped. It's not in order of any particular type of sequence. It's just like one after the other, right? First come, first store, that kind of stuff. Whereas sequential file is more ordered, where you order according to a key field. So it might be a customer number. So you will go in a sequence like 1, 2, 3, 4. So there is a particular type of order there. Both methods are very useful when we're storing data. And we're going to be looking at these in a bit more detail later. And finally, direct or random access, that's basically a method of access in which a record can be found without physically reading other records. So you simply say, go to customer number 758, and you go directly to 758. You don't go through 1, 2, 3, 4, 5, 6, 7, all the way to 758. So again, we're going to be looking at that. So whenever you come across the term random or direct access, that means you're directly going to that record that you want to find without going through all of the previous records. So let's begin with our first subsection for today, which is file organization and access. You need to show an understanding of the methods of file organization and then select an appropriate method of file organization and file access for a given problem. So this is going to be perhaps scenario-based in the exam for you. So let's test your knowledge about how different devices access data. Start with this one. Well, hopefully you've said this is a magnetic tape. So that means the tape plays in one direction and you have to go through every single thing. So it's more or less a serial mechanism of accessing data. What about these two? Now, hopefully you picked up one is an optical storage device, perhaps a CD, and the second one is your iPhone. Now, both of these can directly go to a particular record. You don't need to go to any of the other records. You can just find exactly what you want. So these are going to be direct access. They can also be sequential because obviously you can store data in a record, track 1, track 2, according to the track number, or you might have contexts which are in a sequential order. So sequential is also possible here. Now this is very important for you to remember that depending on the context or the use, different types of mediums or devices can use different types of file organization and file access. So just be aware of what the context is actually telling you. So if you're just going to store a sequential series of tracks on a CD, brilliant, that's fine. It allows you to store a sequential file organization, but yet at the same time, they might also allow you to have direct access. And the same might apply to other mediums where you might have serial and sequential. So just look at what the scenario is actually telling you before you decide. We're going to be looking at that in a bit more depth in a moment. There are a lot of different types of files, and you probably have encountered this already when you're looking at perhaps different types of picture files or image files, and you'll probably say, okay, there's JPEG, there's PNG, there's RAW, you name it. And each file, each type of file, and each type of file format has been designed by a programmer to store data or store records in a particular way and then access those records in a particular way. That's why we have so many different types of file formats. And that causes a problem for future programmers because suddenly you've got so many different types of file formats. Indeed, you can invent your own file format if you so wish to do so, but it's not going to be universal. It's going to be niche. So what happens eventually over time is a few common standards emerge which everybody ends up using, and that allows you to have some form of consistency with your file format. Now, let's start by looking at the two types of base files that we have. There's obviously text files and binary files. And text files are normally human readable, normally because they have text, which is encoded using an encoding format like ASCII or Unicode. And then everything else is a binary file, which is machine readable, so the computer reads it. Now, the human readable file is often bigger in size, whereas the binary file is going to be a smaller size because you only have binary data and there is no encoding format part of that file that's present. Now, on top of that, there's obviously different formats because 1, 2, 3, 4 in numerical form is quite clearly different from the text form, which is denoted on screen using strings 1, 2, 3, 4. So quite clearly, the encoding format can change the structure of the data. Now, another example that you see on screen is the 4 different bytes, 0, 1, 2, and 3, all storing the numbers 0, 0, 4, 2, 1, 0. So think about how much data we need to store extra by just storing the zeros instead of 4 and 2, 1, 0, which is where the numerical values lie. Again, this is something we will talk about a bit more when we go into magnitudes and mantissas and exponents and all of that and floating point representation. But think about this way. Using a string format can lead to bigger sizes compared to integer or numerical format. We need to break down that real-world representation into numerical form at the end of the day. So binary files often end up executing faster than text files, which require that little bit of translation as well. Now that's just to kind of give you a flavor of how data is stored. But how do we organize this data? And there are 3 key ways. The first one is obviously serial access, which is unordered. Then you've got sequential access, which is ordered. And then you've got random access, which doesn't have to be ordered, but to find the exact data, there's an algorithm, which probably is a hashing algorithm that allows you to directly go to the record that you want. So pause the video and just have a look at serial access and sequential access and random access, and especially those numbers. You can see that a serial access is just accessing 1, 3, 7, 2, 8, 6, 4, 5. Data is probably stored in the order it came in, and you just access that. Sequential, the data is ordered 1, 2, 3, 4, 5, 6, 7, 8. So it's probably sorted in a particular way while it was coming in, and then the storage is accessed in a sequential order. And random basically uses a special algorithm, so we don't frankly care where the data is stored, is that you can access each record because there perhaps are pointers in place which point to the next in the sequence. So 1 jumps straight to 2, which jumps to 3, then jumps to 4, 5, 6, 7, and 8. So it's a combination of a serial organization, and perhaps a direct access. So let's start by delving into each one of these organizational methods in a bit more depth. So let's start with the serial file organization. Now, the serial file organization method physically stores records of data in a file one after another in the order they were added to the file. So the new records are appended to the end of the file. Now, these are normally used when we are creating temporary files, for example, storing customer meter readings for perhaps gas and electricity bills. And once these are stored in the serial file, these will probably be created into some kind of sequential order, and then you print the bills out and then you send to the customers. So each transaction, each reading, each meter reading perhaps, is added to the file in order of arrival. Now, sometimes in exams they say, are serial files in any kind of order? And most people will simply say, no, serial files are unordered. Well, quite clearly they are ordered, and the order is a chronological order, which means they are in order of arrival, okay? Just make that distinction very, very clear in your answer in an exam. Serial files are not just disordered. They come in a particular time-based or chronological order, and they are stored based on that. Now, the sequential file organization method physically stores records of data in a file one after another, so in a given order. And the order is usually based on a key field of the record, so it could be a customer ID, it could be a meter ID or something like that. So it will always have a unique identifier. So it's kind of like the primary key of a database. A file could be used, for example, by a supplier to store customer records, again, for gas or electricity, in order to send regular bills to each customer. And these records or these bills will be stored based on that customer's ID number. And all the records are sorted or stored in an ascending customer number order, where the customer number is that particular key field which generates this unique record or this unique bill. Now, new records must be added to the file in the correct place. For example, if customer 5 is added to the file and the original record structure was 1, 2, 3, 4, 8, then 5 will need to come before the 8 and not after the 8, which would have been the case in a serial file organization method. And an example that you see on screen is about a set of students whose records are stored on a computer, and data could have been stored in alphabetical order. It could have been stored in order that they came in, or by age, with the older students coming out first. Whatever method is used, the data has been arranged so it's easier to find a particular record. And if the data is in perhaps alphabetic order of name, and the computer is asked for a student whose name is Zhao, it won't start looking at the beginning of the file, but at the end, and consequently it should find the data much faster than going through each record using a linear search. A file of data that is held in a sequence, therefore, is known as a sequential file. And it uses a key field, which is basically a unique identifier to ensure that the sequence is organized in order to help us find things quickly. Now, the next and the final one is random file organization, and this method physically stores records of data in a file in any available position. The location of that record in the file is found by using a hashing algorithm, and we'll probably be studying hashing algorithms in a lot more detail later on. And this hashing algorithm is applied on the key field of a particular record to help us, again, find data quickly. Now, a file that stores data in no order is very useful because it makes adding new data or taking away data very simple. In any form of sequential file, an individual item of data is dependent on other items. To go back to our alphabetical order of students, Jang cannot be placed after Mahmoud because it's in the wrong order, so we need to do some kind of processing for it. And what would be really wonderful would be that if you looked at the data that is to be retrieved, the computer could automatically work out where the data is stored. And that is the role of the hashing algorithm. So what's the common differences between the three? Well, the serial, you just have first, second, third, fourth, fifth, sixth recorded in order of arrival. Sequential will use a customer record. Again, it'll put things in order because now you've got the primary key, perhaps the customer ID number. So customer 1, 2, 3, 4, 5, 6, it'll be an ordered list. It can be ascending or descending order as well. Random will just be any type of customer. There will be perhaps a unique identifier, but we don't care which order they arrive. So according to the same order of arrival or timestamp based or chronological order, we just store the records 6, 1, 5, 3, 2, 4 in whatever position it is in the file. But to access the actual customers, we will apply a hashing algorithm to them. So the random is quite useful because it takes the best part of the first one, which is the serial organization method, where you can store anything in any kind of order. You can remove things. It doesn't affect the sequence, and the retrieval of information is also very, very quick. So it's using a unique identifier, which is the best of the second type of organization method, which is the sequential one, and it can apply a hashing algorithm to find records quickly. So really useful. Okay, let's take a bit of a pause here and check whether we've learned anything after all of this. So time to apply your knowledge. Pause the video, and on screen you see a couple of questions. Go through these and check whether you understood what we were talking about. So I think the first one should be pretty straightforward. Terms used, machine readable, contains binary data, things like that. Difference between binary file and text file, again, should be pretty straightforward. Text files use some kind of encoding mechanisms. They're more human readable, bigger file sizes, those kind of things, whereas a binary file is machine readable, small in size. Now, binary file might be organized for serial, sequential, or direct access. Explain the difference between the three types. Serial is in order of arrival, whereas sequential works on a unique identifier and is sorted. Random is again stored in order of arrival, but it also does have a unique identifier where you can apply a hashing algorithm to find records quickly. Now, give an example of a file used for which a serial file organization would be suitable, temporary files, and you can give any sensible example. An example of file used when direct access would be advantageous, and again, that's something you could pick up when you want to search for something. You don't want to go through every single record to find what you want. You want to directly go to the record you're looking for. So again, a suitable example you can do and justify your choice accordingly. So we're going to move on to the second part. So that was file organization. Now we're going to be looking at file access. So yeah, we stored files. Data can be stored in records, and the records could be stored in order of arrival, or they could be sequenced, or they could be using some kind of direct mechanism using pointers or whatever. So we've done all of that. Now, how do we access and find information? So an understanding of methods of file access is crucial. Now, there are different methods of file access, just like there are different methods of file organization. And what does it mean by file access? Well, it's the method used to physically find a record in a file. Now, sequential is one of the most common one. It searches for records one after the other. And sequential file access is used for serial and sequential files because you're going to go in order of time or a customer number, perhaps. Now, for serial files, it checks every record until data is found until the end of the file. Data is always appended to the end of it. So in serial files, we will just use a typical linear search, and we'll just go through every single record one by one until we reach the end of that particular file. And for sequential files, every record or key field is checked until the key field of the current record is greater than that of the record being searched. The rest of the file does not need to be searched at that particular point in time, as any new record is then inserted at that particular point. So sequential access is efficient. For example, when we're searching for records in monthly billings or payroll systems and we want to find things across. And we could, of course, use linear search, but here, because it's ordered, we could use binary searches to make things even more quicker. Now, direct access is a method which can physically find a record in a file without other records being read at all. Now, both sequential and random files allow you to directly access data in. So remember, sequential access can only be used in serial and sequential files. direct access can be used in both sequential and random files or direct access files. It's often quicker than sequential accessing in finding specific records. For example, finding a customer's record to change their phone number is a lot more quicker using direct access. For a sequential file, the key field is normally used. An index of all the keys is kept, and this is searched instead of the physical record itself. Now, for big files, searching the index normally takes less time than the actual file. For example, let's just say we have a customer database and each customer's record is, let's just say, half a megabyte. Now, if you're going through each half a megabyte record, and then going to the next half megabyte record, it'll take a lot of time. So instead, what we do is we take the customer ID perhaps, and we create an index based on the customer IDs, and we just search that. And that might be a few bytes worth of data that you need to look through. So for sequential files and using sequential access, you in effect kind of have like two files made. One is the original file, and the other one is an index of the primary key or the unique identifier or the customer ID in our case of that file, and that file is quicker to search. Now, if you're using direct access with random access files, then you normally use a hashing algorithm, which is used on the key field to calculate the address of the record, and that's even more quicker. Now, we're going to be looking at this in a bit more depth now. So do pause the video and take a bit of a break because we've been going through file organization and access for quite a bit. When you're ready and you've had your break, press play and we'll continue with this subsection related to file organization and access. Now, in the context of storing and accessing data in a file, the hashing algorithm is basically a mathematical formula which is used to perform a calculation on the key field of the record. The results of the calculation normally gives you the address where the record should be found. And hashing algorithms are not only used in accessing and finding data in files, but they're also used in encryption of data as well, where more complex hashing algorithms are used. And perhaps you might have encountered hashing algorithms when you were talking about SSL and TLS in year 12 or at IGCSE. You might have come across the term, but we're going to be looking at hashing algorithms at this particular point in time in the context of file storage. Now, before we delve into hashing algorithms in a bit more depth, the problem with hashing algorithms is that often you could arrive at the same answer, which leads to something called collisions. Now think about this. If it's a mathematical formula, then you could just simply apply this mathematical formula on a different set of numbers and end up with the same result. So you can end up with two sets of records being stored at the same address. That's what we mean by a collision. And we're going to be looking at some mechanisms to deal with this as well today. Okay, so let's start with a simple hashing algorithm. Here's an example. You take a key field, you divide it by 2000, the remainder is the address. So if 3024 was an ID number, you divide it by 2000, which kind of gives you 1024 as the remainder, and that's your address. Now think about it this way. You could also do 5024, and that could be an ID number, and you divide that by 2000, and that also ends up giving you 1024 as remainder. So now you've got two separate records or IDs which give you the same address, and that's what we meant by collision. Now, quite clearly, this was a very basic algorithm, a very basic hashing algorithm, so you can make it much more complex to avoid these kind of simplistic errors. However, no matter what type of algorithm you do come up with, there could be the mathematical possibility of two records getting to the same answer. So there are two ways to deal with this. The first one is called an open hash, where the record goes to the next available space. So in this case, if two numbers come up to 1024, the second one will be stored at 1025. And then if another number comes to 1025, that will be stored to 1026, the next available space. That's called an open hash. An alternative is also a closed hash, where you create an overflow area, which is perhaps a secondary space or a secondary file, which is set up, and then the record is stored in the next free space in that overflow area. So you say 1024, if another record comes up to 1024, open a new file, which is called a 1024 hash, and in there, in position 1, you have the original record, and then in the second position, you have the new record. So when reading a record from a file using direct access, the address of the location to read from is calculated using this hashing algorithm, and the key field of the record stored there is read. But before using that record, the key field now must be checked against the original key field to ensure that they match. If the key fields do not match, then the following records need to be read until a match is found, in the case of an open hash, or you need to check the overflow area, which needs to be searched for a match, which is called a closed hash. Okay? Now, one of the best ways to deal with this is to code a hashing algorithm yourself. Perhaps you might want to code the 2000 based one, divide a primary key by 2000, and the remainder is the address. And then how would you deal with an open hash and a closed hash? You might want to put some thought into that. So create your own algorithm, or if you want to code it in Python, feel free to do so. Now, hashing algorithms can also be used to calculate addresses from names, so they just don't work with numerical data alone. An example is adding the ASCII values for every character in the name and dividing this by a number of locations in the file. This could be used as a hashing algorithm as well. So technically, any type of data, image data, sound data, could be used in some kind of algorithm to work out a hash or a hashing algorithm. So what is a hashing algorithm? Well, it's a mathematical calculation or algorithm applied to find the address of a given record, and a hash is the output from a hashing algorithm, just a sequence of numbers that are the results of a hashing algorithm applied to some data. Now on screen you see a hashing algorithm for quick data storage and retrieval. You got some initial data which is converted into a value which is fed into the hash function. So the original sequence could be a bit of ASCII code, which is written up, that's fed into this hash function, which then applies a mathematical calculation to it, and you end up with the address location 1, where this data is now stored. So the same thing happens for the second one, where you again convert this to an ASCII value, which is then a mathematical value, which can be used in a calculation or your hashing algorithm, and that gives you the position 3, where you store this data. So hashing can also be used for quick searching, insertion and deletion of data from data structures. And all you're thinking about is just an address table, which is held in memory, where you simply have the addresses and the data stored. So data being the primary key. Now, by using hashing, we don't need to search the data structure or the file to find the entry. We just input what we are looking for. We apply the hashing function to it, and then we find the item from that. The items don't even need to be sorted. And on average, hashing provides a constant 0, 1 time complexity using the big O notation. And we're going to be looking at big O notation later, but it's phenomenally fast. Okay, that's the end of the session for today. Hopefully you've understood the difference between direct and sequential file access. You can give examples of a hashing algorithm, and perhaps you could even create one. You know the difference between the different types of file organization methods, which are serial, sequential, and random, and the two main file access methods, which are sequential and direct. You should also know how to apply these to various different contexts. That, for example, if you were trying to store data from a weather system, which is sending data per hour, what type of file organization method would you want? Well, in this case, serial, because you're just simply timestamping it. Or if you were trying to print out customer bills, you will probably say sequential. Or if you were trying to find out data for a particular customer, so you could change their phone number for an e-commerce site, it probably will be direct access. If you do have any question, please do let me know. Otherwise, I will see you in the next lesson.